Hello, welcome to my second video. The first video, if you haven't watched, was about the whole architecture of how this email plugin that I talked about in the first video works. Um, we talked about, I'm just going to give you a recap. You want to go deep into it, how I build the local cloud inference for the app, check it from my video. So what this basically talk about is there's an incoming email gets into your Gmail, for example, because that's the entity we have for now. Then before it gets to the UI, there's an authentication which in this case for Gmail we're using Google. So let's get wherever it's accessing our services. Then it gets to the LMUI in Gmail. Then from there it's encrypted because we realize that handling emails are very sensitive. So securing your emails from any attacker is very, very key, and it should be by default, non-negotiable. So what is encrypted there is then sent to the backend server, which is pretty like an interface between every component in this project. From there, it then calls an RPC server, which I call the RPC agent, because that is where the interaction between the LLM and our service is. I mentioned how we had the custom LLM, which we fine-tuned to meet our specific needs because of latency and rest, which also is talked about in the video. So I haven't talked about a brief overview of an architecture. Let's look at the demo of the app itself. Before I go there, let me show you a bit of my my logs. Like I said, we use Docker for the containerizing everything so that it's compatible with ECR on AWS if you need to, or maybe the app platform in DigitalOcean. In this case, we have something similar using Docker Compose way to reach out to both internally and communicate with each component. As you can see, we have two servers here. We have the add-on client and the RPC agent. The add-on client is the main backend server here, and the RPC is the one that I call the RPC agent here. That's what houses the RPC agent here. So let's check for my email. Let's choose the email client first. Oh, I also have a tracing going on here. I'm using OpenTelemetry, so with that I'm able to clear logs and traces, and you can see it here in Cygnus. Let me refresh this because we should have a plain data here. Let's use the last 5 minutes, so there's nothing going on here. Okay, so here let's open something that's not that private here. So for example, there's a connection to the backend. As you can see, the logs are going on here. It starts here. So this is like the first data I'm calling, and I talked about how for a start it's always expensive because there has to be like one of the server, which we then capture the first time. So as you can see here, we have loaded the model. For now I'm using CPU, so even with that it's still really impressive. There's a work completes, and it starts running the inference, and we got our label. So our label, we having our unique label. It's not a typical the model we found from. It's not a typical common like the GPT and the rest. I've gotten the classification, but we don't need to go deep into this out of the scope of this demo. So we have two labels. We have the label and the score, and this is label 0, which is like the first. This is what for label 0 means ham. Label 1 is spam. Label 2 is phishing. So once that is done, we get our inference results, and as you can see, the request is done, buffer done, and the request is sent to the front end, and we have a response, and that is what you can see here. It shows that hey, how that is correct. So we can also have a couple of one. I think I have this that will most likely show spam because it's a job email. As you can see, it's now faster compared to the first time. We could run multiple ones, and as you can see now, going forward, the results will be just be running the inference model. There's no need of warming up the thing anymore because it's already running, so it's a bit quicker compared to the first time. Same thing with this. Let me see this as well. So most of all these ones will showing spam because it's not real. It's not directly meant for me. This looks more real. It's almost like a show harm. Okay. So I have this demo page where I created this phishing email. You could add anything you want to test running. This is most likely phishing because PayPal alert, it's not real. Your account is going to click here to verify immediately. It's like a very phishing email. Because if it's from PayPal, it's just show paypal.com or whatever their stuff is. So if you analyze, it shows phishing and the confidence level, and it even shows the response time. Like I said, this is CPU. For GPU, way faster. And now let's see how the tracing is for this. Let me add more time. I think last 15 minutes, increase the page to like 25 pages. Okay, so let me look for a typical one that is an add-on. Let's look at this. Let's look for like the main one. What's the service name? Add-on. Spam router. I did make some adjustment before now, so most of the logs are not captured, and I wanted you to capture everything. To capture even the ones from the RPC, but it's only capturing the ones from, which is fine anyway. So for a typical return on, let me click on this. Let's see. Okay, yeah, this is a bit detached, but as you can see, the typical inference response takes about 253 milliseconds, which is the Spammeter API, which this is what calls the RPC caller, and this is what actually handles the LLM. So it takes about 253 milliseconds. So yeah, that is a sign that we're having a faster response to our API. As you can see, there is one even going as low as 109 milliseconds. And that's how cool it gets after the first time anyway. So yeah, and you might be wondering, how does the Ngrok, which I mentioned in the previous video, for Ngrok we have, as you can see here, it's having a very good success rates. Sorry, okay, this is the demo page which we called, and this is the one from the email, which I said if you're going to connect to this one, it's going to get a rate limit error. So if it does it, after a while, you can access it anymore. So yeah, that is a brief demo on this. And if you like to learn more, just reach out to me and let's talk. Thank you, and I hope you enjoyed this. Like I said, I'll do more of this, and this is fun.